how it goes. As always, not to it's going live on YouTube. As always, not to make things boring from the start. Let's choose some warm-up problem. It will be easier than the rest we will do today. I want to do some medium difficulty problems around 1800. So, is this Division 1-B? Oh, this is a hard Division 1-B. Can I in some way filter by range of difficulty? Okay. As a warm-up, let's choose something in this range. And hello everybody in the chat. Lakshay, of course, as always first. Jit, Cryptic. Cryptic, you are not the first. Lakshay is always the first. But close. So, hi everybody. Let me know what you think about this chat placement, and we'll see during a stream how often I will, cover it with white so you cannot see everything. I understand this is some disadvantage, but on the other hand, more part of the screen will not be covered by chat. Also, I moved the camera down because more often I use this space here. The messages disappear after 15 seconds. That's also something I can tweak. Or, sorry, 20 seconds actually. No, today we won't do less than 1500. So warm-up will be something like this. One of those two. Chat, do you know those problems? Any recommendations? Which one is better? Deleting divisors or price fixed? Yes, the stream is early today. I was supposed to stream yesterday in the evening, but I was busy, so instead we have today. I cannot do today evening. So price fixed or deleting divisors? Deleting divisors is better. Yeah, no easy problems today. Alright, so let's do deleting divisors. Here's the link for you. Where is it? Close the tab. And let's solve it. There is n. You can subtract from n one of its divisors that isn't 1 or n. If you get a prime, I mean, if you receive a prime, you lose. There is a 4 here, subtract 2. I see. So if in the input there is a prime or 1, then you cannot do anything. Otherwise, you have some number of possibilities. In particular, you can very often subtract 2. My first thought was that maybe, just maybe, the number of numbers we can get is small. And maybe it can be proved that no matter what Alice and Bob do, they only get numbers that are actually divisors of n, or something like that. But I don't think that's true. I think that we can get linear number of numbers. In particular, if you start from even, you can subtract 2. And Christmas t-shirt. Yes, it is. Kudos for remembering. Right now I have no idea how to do this. I can implement a brute force to see who wins for numbers up to, say, 100, and I can try to notice a pattern. Try drawing. I don't know what to draw here. I can draw what numbers we can get starting from, let's say, 20. Early stream in history? Not really, I did some morning streams. If Timothy suggests drawing, I will try some. Brute force spoils it, so let's try to do it without brute force then. If I was out of ideas during a contest for like 5 minutes, I would try brute force. Especially because here it's very easy to write one. It will take 3 minutes maybe. Memorize TP. Only if n was very small. I don't agree that n minus divisor of n has the same divisors. Let's say as an example. Anyway. Oh, sorry. I need to answer the door. Back. Okay, somebody said that after subtracting a divisor we still have the same divisors. I need to remember about increasing the size of the statement. I don't agree. 10 is divisible by 5. After you subtract 2 you have 8. 8 has different divisors. By the way, this was my very first thought here as well. Like maybe something doesn't change. Still, let's make drawings. How does this look? It's fine. Let's start with 20. Right, we cannot subtract 1, we can subtract 2, you will have 18, 4, 5, right, 16, 15, anything else? 10. You can subtract one of the divisors. 18 unlocks many more possibilities. Also, there are possible edges like this one. Maybe that's important. If this is a losing state, then this is a winning state. I don't know if this pattern... Okay, let's focus on just this part. If 16 is losing, then whoever gets 18 can get to 16 and they will be winning. So if this is losing, then this is winning. And because this was losing, then this is also winning. But maybe 16 is winning. Because, for example, from that you can get to 8 or something, and 8 is losing. Then can I say something about 18? Or about 20? I cannot. They would go for the highest common divisor. I don't know why that's true. It's not that they want to... what do you mean common divisor? You get a number, 20. I don't think it's optimal to just subtract the biggest divisor. Is this Slavic's problem? I don't know. Is this Slavic? He changed his nickname, right? Yeah. It is. Did I watch Euro? Like single match. I see that Timothy also gave me another hint in the chat, but still I want to investigate this, because this is what I would try during a contest. It's strange that I wanted to start with an easy warm-up and here I struggle. Okay, 18 unlocks, for example, 9. No other number here unlocks 9. So if 9 is losing, that doesn't really matter. I'm interested in the fact that one of those will be losing, because then 20 is winning. Glad to solve this during the contest. What's your rating, Timothy? If it was a contest, you would have submitted a solution 5 minutes ago? I don't know. Maybe if I did brute force, like by now I would look at this drawing, I wouldn't have any ideas, I would implement brute force. I will here for a few more minutes try without one. 1900s, all right. It also matters what are the previous problems. Like if you have 2 hours for something, that's easier than if you have half an hour. Early gang, hi. Maybe I should start looking from small numbers, like 1, 2 are losing. I will do brute force in my mind. Still trying to do this without using computer, just imagining I only have access to a piece of paper. So marking losing states. How did I do that? Yeah, like this. 1 is losing, 2 is losing, 3 is losing, 4 is winning. Well, all the primes are losing for sure. The winning state, because you can get to just any prime. Right, you can get to 3. Then from 8 you can subtract 2, and that's unusual. 8 is losing. That's the first non-prime losing value. What about 9? You can only subtract 3. What about 10? Subtract 2, but if you subtract 2 you will get 8. And if you subtract 5 you will get 5. Let me know if I made any mistake here. This is winning. 12 minus 2 minus 3, you can get to 9, and that's the only possibility how you can win. No, you can also get to 8. Eight minus 4 is equal to 2. What is happening? I saw in the chat caps lock warning hint. I didn't read the rest of the message. Can I say something in general about numbers that are in form 1 prime times the other prime? I don't think I can. I can subtract q or subtract p. I will then have something like p minus 1 times q. And it's for sure divisible by q. P minus 1 cannot be prime unless p is free. Yeah. I'm still clueless. For 12, this is winning state. Because in particular I can move to 9, I agree. This problem was supposed to be impossible. What is up with impossible problems? Last stream it was the same with some cut cycle problem. Can I give a hint? I don't know. It's disappointing for me not to solve problem rated 1700. So I would prefer to do something like this myself. Like if I struggle really for like 20 minutes, then maybe it makes sense. Right now it's only 15 minutes. It's almost there. Give me 5 more minutes without any hints. I can continue checking what happens for numbers like 14, 15. 14 gets to 7. Any number of form twice prime is winning. And a lot of small numbers are of this form. Maybe I should think about going up. If something is a losing state, let's say p times q is a losing state, like this, then it means every bigger number, but okay, then in particular it implies that, how do I want to draw it? If this is a losing state, then p plus 1 times q is winning. Is anything else? Like q plus 1 times p, of course. What about p plus 2 times q? P plus 2 times q. Like twice q would need to be a divisor. But if pq are bigger than 2, then 2q is not divisor of p plus 2 times q. You are a twin? What? Check for a bigger sample? Yeah, I might just do that. I can implement a brute force to tell me what happens up to 100. How show only difficulty for unsolved problems? It's an extension in Chrome. There's an extension, maybe it's here. Get rate, I guess it's that. Problem is underrated because some people just guess the pattern. I see. I see. So maybe getting an idea here without analyzing numbers up to 40 is actually harder than 1700. Going by hand to 20, right. Let me investigate something else. Timothy at the very beginning told me to analyze just numbers of form x times y in general. I have no idea what I should get from this. Alright. I can move from this to, for sure, x minus 1 times y. Or I can get to x times y minus 1. From both of these, assuming that x and y were at least 3, from both of these I can move to x minus 1, y minus 1. But I don't think that's in any way important. I think I give up. Still no ideas. I mean, plenty of ideas, still no reasonable ideas. Something with evens and odds. Don't know why. Think about 2 as a divisor. Right. At least here for this first 13 numbers, only even numbers are candidates. But in general, I don't think why that would be true. Most of these green numbers we see are of form twice prime number, and it's obvious that 2p is winning because you can get 2p. 12 is a first non-trivial winning number because it's, I don't know, this is square of a prime, and that's not very important. 3 times prime. From 3 times prime you can get to you can get to 2p, or you can get to, well, 3 times p minus 1. So what? Still nothing. So now I lost. I didn't solve this problem myself, and now I'm really looking at the chat. A lot of people are saying about even and odd numbers and some powers. Then I guess there is some kind of parity where we always move between one kind of number and the other. Now, that idea cannot be true, because here we see that it's not that there are 2 categories of numbers where we always move between them. So it's enough to check in which category of a number we are, because from 20 we can get to 18 and from 18 to 16. So that idea is incorrect. Still, maybe the solution just depends on parity or something like that. Can I say what's the answer for 2 at some power? 2 at 5th power. Maybe smaller would be 4th power. Let's say this. This is 32. I can subtract 2 or a bigger power of 2. So I can get 1 of 30, 28, minus 8, 24, minus 16, 16. If this is losing, then this is winning. So there are no 2 consecutive powers of 2 that are losing. But I can't say anything more about this. There are categories. Well, as I said, I don't agree that there are just 2 categories and you move between them, because here we have, let's say, a cycle, not really a cycle, of size 3. 20, 18, and 16 are all connected. And I still want to just get hints from the chat, not the full solution. If we have 3 times 2 at cave power, then in particular we can get to this power. We can also subtract, this is if we subtract 2 to cave power. I can subtract 3, so what? To cave plus 1, 2k minus 1. 2 to k minus 1, that's 1/6 of this, so I think it's that. Everybody's saying brute force for the pattern. Why is there color for handle? I don't know. Twitch has colors for handles, and I think this this widget also displays Twitch colors. I still don't know why I cannot win from odd number. Multiples of 2 primes a solution, except to odd prime multiples. I don't know. Okay, I give up. I will brute force the pattern. I don't want to now run virtual machine just for that. Let me use ID1 this one time. Actually, I will need Linux later anyway, so let's do run it. But I'm confused. You can select your color on Twitch, click the chat identity button. What is chat identity? Users in chat, collapse, chat settings, chat appearance. I don't see it. Can be read in Twitch. Congrats. Every prime except 2 is odd, so you always end at odd number. But like if we have a product of 2 primes and they are not 2, I agree that this number is odd, so what? And if you subtract, you will have something even. But again, so what? I see, left of the box. This is where you click to change your color. Alright. I didn't know about this. I don't know a lot of things about Twitch. Okay, that should be proper brute force. We iterate over divisors, different than 1 and end when we consider going to n minus d. If that's losing state, then I'm a winning state. That code would be short if I just here iterated with brute force over this. Let's do that. And then see why I would create a function for something that easy, especially that here we don't even need square root complexity. I messed up. Obviously we need to first compute and then print. Yeah, print after. Gupta, you were right. How is... what's happening? Every even number other than some primes, some powers of 2? Interesting. Two, 5, 6. is 128 is 0. Okay, so every second power of 2 is off. Right, fine. If that's the pattern. Now the real challenge is to understand why this is the case. Yes, that was quite easy. Well, how do I check power of 2? There is C++ logarithm function, right? I don't want this. C++ log, and it works on even numbers. LG. Right, and it works on integers. Right. In some case we print yes, else print no, and else check modulo 2. I should have made this into a function, would be nicer. No. If something, oh, I should print Alice and Bob. Yeah, then this definitely should be a function. First ones. Okay, now, if n is even, by default we return, well, what do we return? If it's odd, like 3, then the first player loses, and in the game Alice started. So here Bob wins for odd. For odd, if I want to create to return bull here, I shouldn't think whether it's Alice or Bob. If it's odd, then does first win. No, for 3, the first player loses. Now what's logarithm of 2? Logarithm of 2 is 1, and I should have the same verdict as for odds. Yes. If it's odd, then should have the same verdict as for odds. I'm doing very poorly here with implementation. During a contest, I think I would just guess, and I would check on samples if it works or not. If not, I would flip. CLZ for integer log? Well, if there is a function exactly for log, then let's use it. Bob, Alice, Alice, Bob. Okay, 1 is a special case. So for 1 we shouldn't do this. It doesn't behave like other powers, no? I should do it here. And it's not 1. Now it works. 1 is power of 2, I agree with that, and it's a special case where we shouldn't do it. I still have no idea why it works, I don't know what I'm doing, but it works for the sample test. Cool. Now, guys, do we read the editorial or should I try to understand it? Like, no, by just drawing stuff. What do we do? Also, if you ever need my code for something, go to Codeforces, my account, I mean Ericto's account, not yours, and in my submission you can search by, you can scroll to proper date of stream if you ever later want that, and there will be submissions. Understand it, editorial, okay, so I think editorial. Oh, I missed a few comments. Okay, I prefer non-editorial, even though the audience is kind of split. So, why does this work? Assuming that odd states are like this, there are a few things we need to say. We need to say 1 can't go odd to odd, because otherwise one odd would make another one losing. Wait, what do we claim? Return true. This means that even is by default winning. What is losing? Yeah. So we need to say why we can't go like this. Always can go from even to odd. From even, there is always at least one possible step to odd. Of course, there will be exceptions, being powers of 2. But if just this was the code, I would need to prove those two statements. Okay, no. Why you can't odd to odd? This is trivial because odd has only odd divisors. Odd minus odd will become even, so this is easy. Why we can almost always, exceptions will be powers of 2, go from even to odd. It actually matters that this is not a power of 2. So from anything that has at least one non-2 prime, so from, let's say, I don't know, this 5 times maybe another 5 times 2 times 2 times 7. Why from this we can get to some odd? That's because we can subtract 5. And from even number we can subtract 5 and we will get odd. So as long as there is at least one odd odd prime here, we can subtract it. We just want at least one odd divisor. Like, let's say we have, I don't know, 100. Then 5 is one of the divisors. We go to 95. 95 is a losing state, so this is a good move for me, and 100 is a winning state. So an exception is some powers of 2. And the third point is what happens with powers of 2. With powers of 2 you can do only one thing. Not only one thing. You can subtract 2, 4 and so on. If from something like 32 you subtract 2 or 4 or and so on, you will get even, and we know that even number is winning by default, so those are bad moves. You don't want that. The only good move you can make is to subtract 16 to get the smaller power of 2. Right? So from any starting from any power of 2, the only reasonable move where you can hope that it works is to go to the next power of 2. So if we start with power of 2, or if we ever have power of 2, the game will just go like this: 32, I can type it, 32, 16, 8, 4, 2, and that's it, done. Hence, just on the parity of exponent here, it depends who will win. I showed why for each of those. All other moves are bad, they are losing immediately, and here we don't yet know if this is winning or not, but as well, if we are desperate and no other move works, we should do this. 2 is losing, so also 8 is losing, 32 is losing, and 4 and 16 will be winning. This is why this is sufficient as proof of solution. How do we prevent it from ending at 2? Oh, because we... Wait. Yeah, good point. MPILY, MPILY. That's hard. Said a good point. We said that by default, even is winning, odd is losing, but that's not true for powers of 2. So this proof is incomplete. When I did this, I assumed that there are no exceptions, being powers of 2. And we said that odd is bad because from odd you can only get to even, and even is losing. Okay, but what happens with... Is there a possibility of moving odd to even? No, odd to power of 2. Because if so, we can hope that this odd is winning because we hit a proper power of 2. So can this happen? Can we have that x minus 3 is 2 at some power, and x is divisible by 3? But from this you will get that x is 3 plus 2 to k power. This is not divisible by 3, so x cannot be divisible by 3. And you can replace this with any unknown odd number. Say, I will say just odd. Odd. Okay, that's stupid. Let's say p. This is not necessarily d, divisor. Now, if we want this to be true, if we want to get from odd to power of 2, then this must be true, which means that, and we could only do it if d is divisor of x. So here we want x to be multiple of d, but it means that 2 to k power, this must be also multiple of d. And that's only possible if d is a power of 2. Well, it cannot be 1 because we cannot subtract 1. So we have that d is also 2 at some power I. Otherwise this wouldn't be divisible by d. And this cannot be odd unless it's 1, but you cannot subtract 1. Now this is done. Now we indeed proved that from odd you can only move to even numbers that are also not powers of 2. I will write down this lemma because it's quite important. Lemma. From odd you can only go to even numbers that are not powers of 2. And we proved the lemma. Then the other thing was that from even you can always get to some odd, unless this even is power of 2, and it was a special case. Now I think this is done. Right? Any mistakes here? Oof. Now, editorial. By the way, I like the fact that here in the editorial the code doesn't use some random C++ function, like log or something like that. I think it's better to teach people how to do basic for loops. if I was to, actually maybe I should have done it during this stream because it's also to teach you stuff. I think people should use something like that like 1000 times, then they become very efficient with for loops, and then they can switch to some built-in function. Trailers Division1-B next? Maybe. If n is odd, subtract an odd divisor. If even, we prove that odd numbers are losing. How? Okay, so they covered this thing that I missed first, where what happened. Is it possible that odd goes to power of 2? If n is a power of 2. The only optimal move could potentially be to have n. Yeah, so technically this sentence isn't correct. The only optimal move is to have n. In some cases it's not optimal because you don't have anything optimal. You always lose. You can argue that then all moves are optimal, but then it's not true that the only... Anyway, this is a lie, but could potentially be. Using loops also helps Java Python users? Exactly. So by using in editorial something like log function from C++, you would make it only for C++ users. Right, what do we do next? Now after almost an hour on a warm-up problem. I think I will do only 2 problems today with this speed. Right, so now we want to go higher difficulty. This one was lower because people guessed from a pattern. Log calculates logarithm. Yeah, but they will try to use some floating point functions. More impossible streams with easy problems that are actually very hard. Mm. $2,300. Let me hide this. No. If the proof was needed, would you rank this problem higher? Oh yeah, much higher. Yes, I'm sure that most of people who solved it would struggle a lot proving it, and maybe even I would argue that the number of accepted submissions would be like 5 times smaller at least. Aditi, I will not... first thing is that now I do Codeforces problems, not interview problems. Second is that I prefer to just focus on problems from platforms, including LeetCode, not just something from the chat copy-pasted. 3R, okay, so 2 people suggested this problem. It's a little bit harder. Actually, how hard is it? Well, 15 minutes hard. A bit scary. Maybe something easier, please. What else do we have? Somebody suggested Shurikens, 1700. Any other suggestions? Not hard, just not trivial to write. You know, hard. Like, for somebody experienced, sure, this proof was easy. But I'm sure that a lot of Codeforces Division 2 users are not experienced in proving stuff formal. I have quite a lot of experience, and yet I missed something that I did very wrong, where first I said from odd we always move to even something something, and then I completely missed the fact that what happens if from odd you move to power of 2. My proof was just incorrect. Sure, it was close to being correct. It was easy to fill that gap, but you wouldn't get accepted with that proof. What tiling window manager do you use? Nothing special, but in the background we see Linux. Okay, let's do Shurikens. No. Easier one, so maybe this one will be a good warm-up. Here's the link. There are shurikens numbered and costing from 1 to n. Sometimes we take one of them and put on display, on the showcase, and sometimes a ninja comes and takes the cheapest out of those in the showcase. Should place another shuriken on the showcase, I guess a random one. Somebody said expected value. I thought it will be about expected value. I don't know. Yeah, somebody in the chat said expected value about one of the links, I guess. But here I don't see anything like that. Tree array. Oh, I see. Then maybe tree array will go next. So this will be warm up before tree array. We take one of those values and we put it on the showcase. Somebody comes and takes x, and x at this point must be the cheapest. Is this consistent? We need to say yes, no, and also reconstruct what was exactly happening. Right, so we take something else, then we see that 3 was cheapest. So for sure some of the previous events was free. And we continue, also marking some other item as bigger than 3. Then we grab one more element, we figure out that 5. In quadratic time it seems very easy, I think. But of course it's not quadratic. When will be the next educational round? I don't know. How is it with the time when messages disappear in the chat today? I think it's set to 20 seconds, but maybe 30 seconds would be better. So should I make this time a little bit longer before the chat messages disappear? When will I do any educational video? I don't know, sorry. When I have time and a good idea. Sometimes I have only one of those. So let's say that operations are put, then take 3. I will then mark that this is for sure 3, and this is something bigger than 4. Put, take, let's say 6. What happens? All those will be marked as 7 or more, and one of them must be equal to 6. I don't think it matters which one. So let's say this is 6. Now put, take 2. What happens? Well, each of those is at least 3 now. Now we have those waiting, and well, actually one of those needs to be 2. Those cannot. Right, so always we have here, here, and there, some weighting. Those are actual weighting too. For now, just we know that they are 1 or bigger. There are some that we put on showcase, but still we don't know everything about them. We just know some intervals. And whenever now we have information that we take 5, then first it maximizes everything with 5 or 6, whatever. And second, it changes one of them to be 5. Doesn't matter which one, well, can't be those. So let's say the last item I had, I changed to 5, and now it's already decided. And everything else becomes 6 or greater. Or maybe 5 or greater would be easier to say. Can this happen twice? Exactly once, all right. If we never hit 0 shurikens, I don't want to exactly read what you manga said. For sure makes sense, but here I think I'm getting there. So in what data structure I will keep those weighting? I think a stack vector, something like that. Or vector of pairs. Let's Control Z this a few times. At this moment I would put this as pairs 7, 2, 3, 1, 1, 3. This means that twice we have element 7, once we have element 3 or more, and 3 times element 1 or more. Those are information about those. Maybe I as well need indices to reconstruct, but first let's focus on yes, no answer. Then when I take 5, I check if this number is not greater than 5, because that would be, I would need to say no immediately, right here. Then if this number is smaller or equal 5, then I replace one last item as just 5, I erase it, and other than that, the whole suffix I maximize with 6 by repeatedly doing pop back on this vector or stack and grabbing this. This for sure is amortized linear in total. Won't it also matter if you have 3 which to use? No, it doesn't. Like here, I have 5. It doesn't matter if I use 1 or 3, because I'm going to anyway maximize them with 6. So I can, for example, replace this with 5, say that this is done, because in a second, anyway, everything here gets maximized with 6. So it doesn't matter which of them I take. If it mattered, then sure, I would need maybe a set, date, I don't know, segment tree to get maybe greatest not exceeding 5, anything like that. But here it seems simpler. In many other problems, though, yes, it would be needed. And now this new thing will be 7.2, 6.3. Alright, and we also need to reconstruct, but I always grab the last index, so other than this I will keep indices. What's the output format? Prices of shurikens in order they were placed. Okay, so every put, yes, every put will get an index. Like this is index 1, let's mark it with some different color. This is 2, 3, and so on. Yes, prices are all distinct, that's true. Okay, puts, they get indices, and I will here maintain as well a vector or stack of just indices to be used. Here, right now it will be 3, 4, 6, 7, 8, 9 maybe, if also those are available. 5 was already killed, so yeah, 3, 4, 6, this is 8, this is 9. And always when I make a new put, I will just insert a new guy here at the end. And when I take somebody, I always take the last guy. So just grab the last one from here. So blue is kind of separate from white, those two stacks. The size of them will be the same. Like here, the sum of counts of white should always be equal to the size of this blue vector of indices. It's good to know the way how the top coder solves the problem. I guess it's interesting to see. Will this live stream be on your second channel? It's being double streamed right now, so even now you can go to YouTube. Let's verify that. YouTube Eric Tutu. Yes, it's live. And later you can see all the past streams. There are now, I'm sure, more than 100 of those. Good luck binge watching that. I have trained since last 2 streams, please. I'm busy with some other problem right now, Fenwick. Okay, everything fixed. Right, then let's do some coding. Is this how you spell Shurikens? Yeah. Is scene fast enough that I don't need magical lines to solve this problem, or do I need the synchronizing things, those 2 lines for scene? What does worst amortized mean? You can Google amortized complexity. It means that something like this. Even though one operation can be slow, let's say there are n operations, you do n operations each time you do something. Even though one operation is not necessarily constant, it can be linear. What matters for us that it's often total. Even though one operation each is O of n, or maybe O of 1, or maybe O of n, but they sum up to O of n. That's called amortized complexity. Yeah, I will do O of n with stacks. Why do you make new file for every problem? Why wouldn't I? I don't know, maybe I will need the previous file. So amortized cost, I don't know the exact definition if amortized amortized cost is what we call this average cost, that it's O of n total per operation. Don't know semantics. I guess just Google and read about amortized time complexity. I don't think I ever saw amortized space complexity. Running Linux on VM is not laggy? No, it isn't. Oh, yeah. Now, will this read the first non-white character? I'm not a scene expert, I hope. If there is plus, this is the put operation. What did I do? New thing to blue indices of whiting, and it gets by default 1 plus. Okay. This is the blue thing from the drawing. So we can do this, I guess. blue, so, and this is white. How should we call that? Values, limits? I'm sure that if people don't watch my streams and then they open my code, sometimes they will be very confused, because I sometimes refer to things from drawings. In Codeforces, it is a good thing for practicing to often just go to open somebody's, some experienced guy's code after you solve it, after you fail to solve a problem, and just read their code, see how they solved it. And then if you open my code, well, you will see some colors. Anyway, first it's empty. For put, this is pushback. Next index. Actually, I prefer 0, I guess. Make it from 0 to n minus 1. We will use blue indices to fill answer. So actually this is 0, then 1, and so on. 1. 100 lines of defense. Well, sometimes it has 30 lines of defense. Yeah, improving your implementation by looking how top coders do it. That's important too. So there are two aspects here: how to code in general and how they solve this particular problem. With value 1, 1. I could here sometimes just increase the last group, but it will not modify the time complexity. So sometimes I can make here an if white back, assuming it's non-empty, dot first is equal 1, white back second plus plus. I can do that, but I claim that this version is anyway linear. We can submit both. This is linear anyway because we add linear number of groups. So that's basically it. Faster, but anyway, version. I think that's it for put. Else, this is take. So a minus. If white back, if at the end we see 6 plus, then it's bad if we now get 5. So if this first is greater than x. But otherwise, we take one element from the last group, claim that indices cannot get empty here because I checked if white is empty, not white. That was code limits. Neil Wu has best code. I don't know. I don't remember how he codes. This is the price X. Now we need to get rid of one element from, not white, this should be called limits. So something like limits back second minus minus, and also we erase this if this gets down to 0. So if after subtracting 1 this is equal 0, that limits back that first is equal to 1, smaller equal x, and we maximize it with x. Then actually I don't need to pop this back, do I? Yeah, I don't. We subtract the last count by 1 because I take it. We now count all elements not exceeding x. And we add back limit x plus 1 or bigger. So actually here, including those for better speed. But again, I think it doesn't matter. X plus 1 and the count. And this is another thing that is made n times, so it shouldn't matter for time complexity. Right, I messed up. White, no limits. Semicolon after minus minus. No, those types of mistakes are extremely easy to figure out because compiler will tell me exactly that. I wanted to use cout, so let's use cout. Sometimes it's easier to just type than copy paste. Right. Where's my statement? They close it? Oh yeah, I hide it there. This is empty failed. Line 35. Oh, that was an old comment. Why not add those two fast Iowa lines? I'm curious seeing if this is fast enough still. Damn it. I think I need to just keep using scanf because using scene I cannot, and cout, I cannot just remember and intuitively use them. And every now and then I will use print or puts or scanf. So I guess no more scene. It's too late for me to change. Right. This is empty. Can it happen that the last count is 0? That wasn't it. Oh, assert that not empty. That was a stupid assert. 4, 2, 3, 1. There's spaces. Not new lines. 4, 2, 3, 1. Oh, I already copied those. I don't think samples are very strong here with only one yes test. Still. Yeah, I accept it. 234. And just as a confirmation, I claim that this has the same time complexity. White limits. Maybe during a contest it would be optional for me to go just with name of white if I think about this from the drawing so much. Puts removed after C++11? Really? Oh, what did I do wrong? What is here? Oh, else m plays back, of course. The speed up here is that I don't create two consecutive equal groups. And I'm submitting this only to see if the time is quite the same as this one. Yeah, quite the same, slightly faster. Skim over your implementation. Right, so, well, yeah, let's first look at the drawing. I guess a new one should come handy. Whenever we have a new put, I don't know yet what number is this. By put we mean, showing on the showcase, putting on the showcase. So for now I just know that this is number 1 or greater. We have another put, well, 1 or greater. Now we have take, let's say take 5. Then I know that one of those previous puts needs to be 5, and the other one, all other ones, are at least 6. What happens now if I have another put? Well, it's 1 or bigger, another put 1 or bigger, another, and now take, let's say 3. This cannot be 3, because it's 6 or greater. This can be 3. So I say this is 3, and this I change, well, 3 was smallest among puts so far, including those, so this needs to be greater than 3. That's 4 or greater. Still in game, we have this index, this put and this put, and they are 4 or bigger and 6 or bigger. Let's say now we have another put, it's 1 or bigger, and it's also in the game. Everything still in the game, still not decided. I keep in 2 vectors, the blue and white. We'll figure that later. Now we have, let's say, take 5. Take 5 was already there. Take 7. Well, one of those should be changed to 7, and this is already done. It doesn't hurt to always take the last available guy. Everything else changes to put 8 or greater. Like this. But before that, let's say we have another put here. For speed, I keep the available, so those with arrows, guys, as some kind of blocks. I can keep this arrow thing in this format, but it would grow a lot, and sometimes I need to change a big suffix of this when I maximize with something, because when I have here, let's say, take 7, it means that everything is at least 8, so I would need to change a bunch of numbers. Then take 9 would change everything to 10. Instead, I keep them as blocks. I say that this is 1 repeated twice. This is 4 repeated once, 6 repeated once. And with this, the time complexity gets linear instead of quadratic. So this is my vector limits. Let's see how I maintain a vector of pairs limits. First it's empty, then this version. This version we'll figure out later. Mainly, when we have a take, we want to decrease the last count by 1. So when I had here twice the last item, now it's once, because I just grabbed the last available arrow, this one. I say this is taken, so decrease the last count by 1, that's this line, second of the last pair, because I keep pairs value, the limit value, comma, count. And then I do the maximization. So while in the last pair the limit is smaller than, let's say, 7, because now we have take 7, I erase this, let's say we have only take 5, then I erase those, I maintain the count of how many elements I erased in total, and then I insert, the suffix now is changed to values that should be at least 5, and there were 3 of them, because I counted 3. This is how I update limits. This is amortized off and total time complexity. And when I insert a new guy, just inserting mainly 1, 1 at the end, because every new element is at least 1, like here. I mainly insert 1, unless the first element here is already 1, then another put just increases this count. So that's it about the solution, and there is another vector of indices for me to actually reconstruct the answer. So every put also gets an index. This is first put, second put, third put, and I also maintain them in order to at the end know every put what number it got. Why is it often? Because the only not linear part can be this, right? But here you go. Every put inserts one pair. Every take erases X pairs from the suffix and inserts one pair. These two sentences in total say that the total time complexity is linear, because there, well, maybe proof would consist of this, that, and there are often puts and takes. Because if you insert in total linear number of pairs, like this inserts n pairs, this inserts n pairs, which means that you cannot erase more than n. Because, well, if you insert something 100 times, if you use pushback 100 times, then you cannot use popback more than 100 times. So that's it. The total number of operations is twice, at most twice the number of inserts. That's it. And this is, I think, the most common example of amortized time complexity. The other one is two pointers. Basically, all two pointers problems, they depend on amortized time complexity like this. Previous bigger standard stack problem? Yes, that's true. So the common problem of, for every element in the sequence, find the previous, so most recent, greater element. I'm sure it exists on LeetCode, and you should do it with monotonic stack, where it's similarly of an amortized time complexity. Right, what's the time? Hour and 25 minutes. And I guess one more problem. We looked previously at that tree problem. I don't watch football a lot. Nearest previous greater. I guess so. Most, as we go from left to right, most recent greater. That's, I think, a good definition. Right. So, can somebody give me that tree array problem? Was it just a recent one? It's here. Is this one worth it? And up to 200. That usually means a difficult problem. So, thanks, Smith, too. How long does it take to be a great coder? When was Gennady Korotkevich born? So it takes like what? Maybe also this. Korotkevich won IOI. 2006 minus 94. Your answer is 12 years. It takes 12 years to be a great coder. Assuming that Google answers this right and correctly. 12 years. Including some, time. The first year of two, it's not really that you will learn a lot of coding. So if you have already some prerequisites like talking, then maybe less than that. To win IOI. Right, tree array problem. That would be 52. You mean starting from now if you practice for 12 years? 12 years is the minimum. I'm sure some Chinese participants will prove us otherwise eventually. We need to mark nodes in some order. In random orders they are chosen, with at least one edge to a marked node. So it's like a disease that spreads starting from a random node. expected number of inversions. What's really needed is for every pair of nodes, let's say node 4 and node 6, we should compute probability that 6 is visited before 4. That's a probability of having an inversion. We should sum up those probabilities. It's obvious to me that we need drawings. I'm over 12 years old and not a great programmer, so your answer must be false. Maybe you didn't practice for that 12 years. It's like asking how much time does it take to learn Spanish, and I answer 1 year, and you say, oh, I live for more than 1 year and I didn't do it. Maybe just Gennady practiced from the day he was born and you didn't. Contribution technique indeed. So to understand this problem better, you might want to read this. Here you go. Didn't work? Well, maybe it will work for me, maybe not. Right, there are some nodes. Let's say that we know which node was visited first, and then the disease starts spreading. This is node 6, this is node 4. Then I guess that nothing other than this path between 6 and 4 matters. I don't see how it would matter. We can ignore it. Whenever disease spreads to those vertices, those nodes, it doesn't affect how quickly we will get to 6 or 4. Disease starts from here. Yeah, sure, sometimes it will affect some extra node, or like it was already there, and it will affect this guy, but it doesn't matter. So those we ignore. We also can ignore everything below 6 and 4, just because whenever you get to 6, then you already know if you got to 6 or 4 first. So we can focus just on the path between 6 and 4. And I think there is always probability half that we visit this one or this one first. So with probability half you spread to this one, maybe then with probability half this one, then with probability half this guy, then with probability half this guy. I think there is a formula for this. It's called Gambler's Ruin. This thing. There is a formula where it says that if you have some state, then with probability half you will move left, and with probability half you will move right. Then your probability of getting here first is x. Wait. No, that's not the same problem. Yeah, because there we move back and forth, so the answer will not necessarily be the same. Then never mind. But in particular, I can do it with dp. Right? Like dp, depending on how much, what's the remaining length of distance here. So dp of distance to one node, distance to the other node. And depending on that, I can say what's the probability that I will visit this first guy first. Yes, I'm computing probability. Yes, the sum over probability that 6 will go before 4, 2 will go before 1, and so on. I can write down here. The answer is the sum over probability that I goes before j, where I is greater than j. For every pair of nodes I need to compute this probability that I goes before j, and for those two nodes ij, I just focus on the path between them. Depending on where we have a start, the start can also be outside, but it doesn't matter. So if the start is here outside of the path, then still eventually it will spread the disease here, and then we say we focus there. So for every possible starting node, and every node has 1 over n probability for that, we will eventually reach this first point on the path between 6 and 4, or I and j, and then we care about those two distances. And as pre-computing, I did this. Given two distances, how much we are left to spread, d1 and d2, what's the probability that this will be visited first? And there are just two transitions. With probability half, we go to dp of d1 minus 1, d2. So either we spread to this guy or this guy. So yes, the LCA indeed depends on where we start. I'm famous. What do you mean? Connecting the nodes will make things easier. But this is a tree, everything is connected. What else? I'm guessing right now that n could be bigger. This was Division-1-B problem. Maybe they didn't want to require some extra tree stuff. For every node on the path between I and j, I would need to know how many nodes go outside. Yeah, I see how it would become a mess. But I think this can be done in quadratic complexity. Maybe even faster than quadratic, but then we would need to do this fast. I don't know how. If there is an easy formula for that, maybe we can do the whole thing. Yes, I will consider every root. If I wanted to be faster, then actually for every node on path between I and j, I would say what's the number of nodes growing out of this node, outside of the path. Yep. Very slow solution for this is actually n to 4th power, because for every pair of nodes ij, we can go through all the nodes here, including this one, and with DFS count the number of nodes outside. But if we do it properly, it will be O of n total for every pair ij. If you have this for I, for j, for every, let's say LCA, for every node in the path between ij, and here we run DFS to count, in order to count how many possible starting nodes there are, like including this guy, everything that grows here, everything that also everything here works the same way, like this guy, because eventually you will make this one sick. But to count all this blue, you can run DFS starting from this node and not going there, then when you consider this guy, we'll do a separate DFS that counts all the nodes here, and the sum of complexities of those DFSs will be linear, because no node will be visited twice. So this, even though it looks like n times n, this is O of n total. Actually, I'm not using dp on trees here. This is just probability dp, something unrelated to a tree. and in tree we do DFSs basically. Compute distances from the left endpoint and distances from the right endpoint. How do you distinguish between those two, Mango? If you... no, wait. The sum of those distances will tell you how far away you are from the path. No, I don't agree. I think you're wrong. If you know that some node is 10 units away from 6 and 10 units away from 4, you still don't know where it is. Right? No. I'm wrong. I, J. Okay, I see. If something grows out of this guy, then for I, it's 3 units closer. Because the distance from anything here to I is 3 units closer than to J. If anything grows from this, then for I, it's 1 closer. And so on. So yes, Mango is right. It's enough to run DFS from I to run DFS from J and basically know all the distances, which I can do in quadratic time as the very first thing. I can first, before anything, compute distances in a tree. And then know things thanks to that. Alright, let's do some coding. I will write down a lot of comments and definitions as I go. And this is the last problem today. I won't start new ones. Or we already have a tree problem, a long one. Step 1. Compute distances. For every starting node, we run some kind of DFS. For convenience, when I deal with trees and there are no test cases, I actually like global arrays. It's very easy to create them, and sometimes we have a bunch of them. For every neighbor of A, if that's not the previous one, distance from start same as from A plus 1, and we continue. That should compute distances. Make something with keyboard and microphone. Don't you hear my keyboard right now? ASMR from programmers. If I put my microphone behind my keyboard, I think you will hear the keys better if you want that. No, distances are computed. As second point, we will compute dp. Let's define it. don't see what I'm typing now. Probability of getting disease first to node with distance 3 from the start. Compared to 5, of course. That's the definition. So P-win for if there's 0 and anything, that's 1. Other than 0, but 0 I don't think will appear. P-win for anything 0 is 0. P-win for any different thing, there's half probability that we will go towards I, plus half that we go towards J. I don't think that P-win of 0, 0 will ever be used. Right, done. Girls and water pool. Imagine programming with girls and water pool. It's not ASMR, it's awful. What? ASME? Okay, I don't know what is E. No comments? There are comments, just maybe not the ones you tried. Right, we have this, and now for the first thing there is actual solution. We iterate over every pair of nodes. First, let's do everything with doubles. Oh yeah, I should have done this with modulo billion 7. For every pair of nodes. Dot A goes before B. This is something we need to add to the answer, because that's the probability of inversion. Now, for every start of the disease, we care about the distance to A and distance to B. Well, there's also distance. I don't know if that's useful. There's distance between A and B. That cannot be 0. Now, on this path, the disease first will get somewhere. And as we saw in the drawing, because Mango told us, this difference determines where we will get to the path between A and B first, starting from V. It can be from minus D to D. Particular, this is D closer to I. If I add plus D, then now this is from 0 to twice D, and then divided by 2, it will be from 0 to D. So X is now positioned from 0 to D, like 0 denotes this guy, 1, 2, 3, 4, 5. I think. Then I need to take probability. Let's see. This is big if we are far away from A. It's small when we are close to A. So I think it's correct to say this. x is distance to A. And yeah, that's it. Let's hope that it works. The first answer should be 7/6. That's 7/2. But I should divide by n at the end, because we choose the beginning randomly out of n indices. Now it is 7/6. Cool. Then two other inputs. Five and a half. For yes, this is 5.5. And this is 3.5. Right. It works on samples, so I think it will work always. Then I just need to use modulo. In particular, division by n. Okay, let's do it. The assert x greater than 0 prevents you to go to subtrees rooted at A and B. No, that's not true. It can. Assert cannot prevent me from doing anything, because if assert isn't satisfied, then the whole program crashes. So assert is for me to make sure that I computed x in a reasonable way. If I'm in subtree of A, if I'm in subtree, let's say, of B, then the start, it means V is somewhere there. But the first node between I and J that we will visit is here, J. So the difference of distances from I to V and from J to V should be exactly equal to D. 5.5 from the mod. Well, let's go with smaller value. If 1007 is modulo, then half of modulo is 504, because 504 times 2 is modulo plus 1, so 1. From this you have that 504 is half, so this, and then what did I want to say? No, this is not modulo over 2, 1/2, right? Because here if you look at this, you see that 504 is 1 divided by 2, so just half. Okay, so then you know that this is half. This is 1.5, 2.5, 3.5, and so on. Just I applied the same logic for 1,000,000,007 instead of 1007. For big prime number, it's very easy to compute half of. It's easy to compute half modulo this prime. Similarly, it's quite easy to compute a third. Just a few more operations needed. In general, you can 1/k you can compute in O of k. You can think about it. And this goes without modular inverse. Just like here, in constant time, I got half. Right. So now modulo. But I will need inverse of n. Actually, we can try to solve this problem without modular inverse. That will be maybe more interesting. Right, so here. This is half, if we need it. Multiplication would be nice. Yeah, so this. Right, this is half times this plus that. Alright. This is not without modulo, that's something else. Answer plus that. right? And finally divide by n, that will be the trickiest part. Double, no double now. Just int. Now, how do we divide by n? In linear time. But we know that. What do we know? This is some unknown x. So a is equal to n times x, modulo mod. And what do I do with that? I don't know x, of course. I know n, I know a. A is actually a reminder of something, modulo like billion 7. So it's some integer multiple of modulo plus this reminder. And now we need to here have a perfect equality. And we know that k cannot exceed n, because otherwise the left side would be too big. We still don't know x, but we want this left side to be divisible by n. And here we know x. And what we computed is inverse of n. I was not declared. Oh, I just wanted inverse of 1. Oh, so I could put here answer. That's convenient. I wouldn't do this, by the way, during a contest. It would be faster to just implement an inverse. Yeah, everything works here. Why just don't use mod inverse? So see, I could of course here do modular inverse. I would do it during a contest. Here I wanted to, as educational stuff, show you something else, some alternative, where I don't have any exponentiation something. It's of course slower. This is often for small n. It's fast enough. Right, but I want inverse of actually answer, not answer. I think if we have this, then just x is the answer. Because I found answer divided by n. And then, of course, return 0, just to make sure assert false that I indeed found it. This is what I did. Anyway, it doesn't affect the full-time complexity. Here we have n cubic, and we don't use any modular inverse there. The question is now if we can go faster in this middle part. Okay, accepted. And I guess we can, but I don't see how. We shouldn't then iterate over AB separately, and maybe there will be some FFT on the tree involved. Did you open private teaching sessions? Not yet. Not yet. I mean, you can write an email to me if you are interested in group lessons. When did your messages become 11 instead of 9? Today or yesterday? Oh, of course it's fast enough. Yeah, that I didn't even think about that. N-cubic is always fast enough for like 2 seconds. Sure. Also, I hope today it wasn't annoying with the chat. So right now you don't see the chat displayed because everything is white. If I hide this, then now you see it. I will next time increase a little bit the time messages are displayed. Actually, it should be increased now. It will be from now on 30 seconds. It happened during stream time? Maybe. The idea of camera in the lower corner is that as I said at the beginning, I more often use this part of the screen. This I often want to draw there. Or even when I code. What happens when I code? Well, when I have this on the right, then I again often type something there and I hide it with my face. So this will be better. And I guess the disappearing chat also should be a plus. Why so early today? I just couldn't do yesterday evening, or today the evening would be inconvenient as well. When the messages disappear. Oh wait, I guess I'm sure. Which problem did you enjoy the most? Let's see, what did we do today? Tree array, and before that Shurikens. Shurikens wasn't in any way interesting to me. I think Divisors was the most interesting because I didn't solve it. Oh, also please remind me that I should increase the font size a little bit. Like when I stream, I think this should be a better font size. I could even set it up by default in Genie, but when I do contests, I don't like that big of a font. Like I see too little. The lower the font, the more of a screen I see. But I will try during streams to do this. Same in Codeforces right now. This is 150%. For people who view in lower resolution or just on their mobiles. I solved 3 problems just because Divisors took me almost an hour. Shurikens was easy, so nothing interesting. And a tree problem wasn't a challenge for me, but it was fine. Modular inverse part again. I think it's the topic for a lecture. Maybe we can Google it. Modular inverse. Okay. Let's do it in some other way. Okay, I see. So this is the last thing we're doing today. Mini lecture, let's say. And the topic is computing 1 over k modulo p in complexity of k. That's the problem we need to solve. Actually, p doesn't need to be a prime. In particular, if p is not prime, then maybe this is easier method than computing something to mod minus 2. This is what we want. Let's say that you want to compute 7 to minus first power, or third will be more interesting. No, one of those two. Modulo 10. Okay. So you want to find modular inverse of 7, modulo 10. How do we do it? Well, I'm looking for such a number x that is equal to 1 over 7. Okay. In OneNote I have this auto computing of anything. So we have 1 is equal to 7 times x. Well, if x is 0, then actually that's one possibility. You can iterate. If x is 0, then the right side is 7. If x is 1, 0. That doesn't work. Right side is 1. Not 1, 7. So I'm looking at this. I want to satisfy this, modulo 10. And I try various x's, because I don't know what x is. I can continue. For x equal to 2, r is 14, which is equal to 4. For x is 3. R is 21, which is equal to 1. Done. So x is equal to 3. I found such x that after multiplying by 7, it has proper remainder modulo 10. Remainder modulo 10. Computing inverse in our case, just solving the same equation as Euclid and just about time complexity. Yeah, it is brute force. It is as easy as we can go. But the solution I showed here, I believe this is O of modulo. Isn't it? I'm not sure if I showed O of k or O of p. How high can this go? Yeah, O of mod. This was O of mod, and we need to be better than that. In particular, if we wanted to compute 1 over 2 modulo 1,000,000,007, we would have a hard time with this method I showed, because we are looking for something where x is equal to 1 over 2. So 1 needs to be equal to 2 times x modulo 1,000,007,007. And using this method, what we want to do is the following. X is equal to 0. Well, the right side of this equation is 0. X is 1. Right side is 1. No, 2. And so on. And we would need 500 million steps to eventually get x is 500 million, something. Eventually for this x, you would get that the right side is equal to 1,000,000,008, which is equal to 1. Is there a possibility we cannot find x for other number than 7? Yes. Modular inverse doesn't necessarily exist if mod is not prime. So then so this method bad. What we can do instead is we can see this. Basically 7 times x can be equal to 1 only if some number of times we overflow 10. Whenever we overflow 10, then we indeed take it modulo 10, right? Because something happens when we have 7 times x. When x is 1, we have 7, and for x by 1 bigger, we have 14, but that's actually equal to 4. After 14, we have 21, that's actually equal to 1. So we can actually think that, well, this must be 10 multiplied by something integer plus 1. And instead of iterating over x, we iterate over this number of times we overflow. This must be true for some integer k if we want 7x to be equal to 1 modulo 10. Okay, so instead we iterate over this. And we consider that maybe 7 times x is equal to exactly 1, maybe it's equal to exactly 11, maybe it's equal to exactly 21. And here, bingo, it works. Because 21 is indeed divisible by 7. And here we just work with long logs. There is no modulo here. We want to get an exact equation without modulo. And because of this, we figure out, okay, then x is apparently equal to 3. And indeed, with x equal to 3, we will have 7 times 3 is equal to 1 modulo 10. And this method, I claim, is of k instead of so faster than of mod. When I say mod, that's just p from the statement. I could put here p, whatever. So it's faster than O(f)mod. Yep. Why is it O(k)? Yeah, why is it? Because when you have k is here 7, when you have 7 times x is equal to something, and you know that x is from 0 to modulo minus 1, then you know that 7 times x cannot exceed 7 times mod, right? So in particular this is true. Right, what am I saying? Oh yeah, this is 7 times 10 in this case. So when I iterate here over something of form 10 times k plus 1, and I want this to be equal to 7 times 10, then k cannot exceed 7. It's log of k actually. No, this method is O of k. Oh, sure, there are other methods. Yes. There is extended Euclidean algorithm, and there is just exponent. Why do I never remember how to pronounce it?
Exponentiation.
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 Okay. So with exponentiation we get log of modulo, with Euclidean we get a log of k, and with this method we get O of k. This is sure very slow, but it's easy, I would say. Maybe not easy. It wasn't easy here to show it and to describe it, but I wasn't ready. But in particular, on pen and paper, this is the easiest you can do to compute half or 1/3. If you need something like this, let's compute together 1/3 modulo 1,000,000,007. Let's say you don't have access to computer even. Then you know that x is... normally I wouldn't write these equations, I guess, because what I know is that we want this to be divisible by 3 or the next number. Okay. This is modulo plus 1, modulo twice modulo plus 1. So those are both 1s. This is 1 and this is 1. One of them must be divisible by 3. I guess this one is. If I didn't do apostrophes, I think OneNote would compute this for me. Here you go. That's inverse of 1. If this wasn't divisible by 3, then this would be. Yeah, this is how I would compute inverse of 3 modulo 1,000,007 with pen and paper, or just in my head, and I could hard code it in code. Right, and now we're done. Hope you learned something new today. Next time we see each other this weekend, I guess Saturday evening. This is the schedule of streams. Why one of them is always divisible? Because the inverse exists. For prime modulo, the inverse of any non-zero number exists. So, and well, this just means that basically the fact that inverse exists exactly means that one of them exists. Like this is 1 divided by 3. There needs to be a possibility to say that some number being in form k of modulo plus 1 divided by 3, this is equal to some x, and then this x is exactly inverse of 3. Or maybe this way. If x is inverse of 3, then by definition multiplied by 3 it is equal to 1 modulo 1,000,007,007. And well, it cannot be just 1/3, you know, like this, because this is non-integer. So there is some integer x being inverse of 3. Multiplied by 3, it will give you 1 modulo 1,000,007,000. So it will be either equal to actually 1,000,008,000 or 2,015,000,000. Is Shurikens a standard idea? I don't think it's that standard. But I would put it in category of greedy problems. Where did I learn basics of C++? I learned it more than 10 years ago. Any source I used is now outdated. This Polish platform I learned from, it's in Polish and it no longer exists. And it was in time where auto didn't exist. Where you wanted to iterate over set, you would need to do something like this. So this was the better version. I don't know if cout existed, maybe. Cout was slower, I think, back then. So this is how I used to type iterating over set S. And actually auto didn't exist, I think, at the very beginning. So something like this, I think, you need to use. If you want to learn this kind of typing instead of just instead of that plus the space, then sure, you can search old Polish platforms and you can learn C++ from there. But if you want something modern, then don't worry how I learned C++ 10 years ago. Do I love math? I like math. I enjoy it. Right. Thank you all for watching, and bye. And quick check if maybe somebody is streaming on Codeforces. No. Again, if you are a Codeforces streamer, you can go just after me and I would raid you on Twitch. Right. See ya. Bye.